Okay, so I could completely remove the battery. What I did, I cut here so the light guide went out easily. So now we will measure all the cells and understand what is the problem with this battery. I guess that some of the cells are not balanced. So 4.7, aha, 3.9, 4.12, 4.15, 4. I think that only one cell need to be replaced in order to fix it. I guess only this cell. Yes, this is the bad cell. Okay. So now what I will do, I will discharge all the batteries till a safe voltage. This is very recommended, and this way I will be able, even if I short something, nothing bad will happen, and I will try to replace just defective cells. So I will now mark it. This is the third cell. 1, 2, 3 from here, 1, 2, 3. This is the third cell only. This is the defective one. So I will now mark the bad cell, and I will replace only the bad cell. But first I will discharge the cells to a safe voltage to work with it. I will do it individually for each one of the cells. This is pretty easy. Yes, I will use magnets, and this way I will be able to connect. Yes. Maybe I will be able to do it without a magnet. No, magnet is the best way. The way to do it, I just put a module magnet on my probes. Let's start with the first cell. So this is the minus and this is the plus. And I will change battery mode to lithium. Okay. Okay, discharging and also checking the battery capacity at the same time. So we'll go one by one for all the batteries and test them. This will take a while. Okay, so I've done some work here, and these are the numbers that I got about the capacity of each cell. One of them is 1400, 1381, 1363, 691. This is the cells that I saw the voltage was lower than the other cells. 942, 1235, which means at least the two cells with the lowest capacity are not good. Okay, so how did I check it? The best way is to charge it and then do a discharge and checking the discharge and not the charge current, because some of the current is going to hit. So now you can see that all the cells was fully discharged, and we can learn from it that they were all fully discharged at the same method exactly. And you can see that, for example, this cell is the voltage is lower than the other cells, which is also not a very good sign. So I will start. I found cells. This from a 9-watt ES2 internal battery. I think internal or external. I'm not sure if it is internal or external. Also check this capacity is 2400. Of course, the best cells is to take all the cells from the same batch, because they will all have the same internal resistance, and it will not be stress one of the cells, because all the cells are connected in serial. Of course, you can see it start from the plus, and then it's go the minus to the plus, and minus plus, minus plus, and all connected together. So basically I can change just two cells, but the problem, the capacity in these cells is much higher. So these cells originally probably was 1500. The original cells of this version of Dyson, I think, the original cell capacity. So now they are safe, more safe, because they've almost fully discharged. So even if I do a short while cutting the wire, nothing will happen because they are discharged. Okay, so I marked the bad cells. These two cells are not good, and now we will try to see how to take them out. One more thing. You can see that the connection between the cells is wide here, and the connection here is much thinner. The reason is that this is the balance. The balance is done with pretty low current, few milliamps, maybe 100, and this connection should be able to transfer at least 10 amps or more. By the way, I've checked the circuit and I found that there is I think I found a 30 amp fuse. I think this is the fuse here. So if you're doing a full short, there is another protection, the fuse in the PCB. Of course, if I'm doing short here, it will not protect, because this is protect just for the voltage that's going out from the cells. So there is no any protection if I do individual short on each of the cells. So we have, of course, here a microcontroller, and the voltage is going through the switch that we seen that you need to press. So probably there is a MOSFET out, that if it is pressed, it is going through a MOSFET, and the MOSFET will stop the current if something is not balanced or there is a problem in the battery, and also it will flash the LED number of flashings that is like an engineering code for the error in the Dyson. So next step will be to disassemble these two cells. We'll do it soon. We'll try to see how to do it, let's say, in an efficient way. Okay, so let's see how we can disconnect the battery without harming and without destroying anything. So I will use the plier. I will try to use maybe screwdriver. And another thing, searching for a knife and a knife. Okay, so let's see. So first battery I want to disassemble is this one, and you can see the eclipse here. After cutting this part, I can lift it and take it out. Of course I need to cut from both sides. So let's see. Let's see, by the way, the voltage of this battery, what is left from it. It's 3.39. Okay, it is discharged. Okay, I am trying first, maybe from the middle to see if I can open it. I also need to disconnect this one. Of course, the best practice, if I can disconnect the soldering part. And even if not, I want this one and this one both. You can see that it lifts up easily.